systematic error. Systematic error, right? So what's systematic error? Let's say we measure the height of a person, say a boy in a classroom. So this boy, let's imagine that this boy stands next to a ruler by the wall. So this is the wall, that's the wall, and at the wall, let's say there's a ruler or some markings on the wall. Okay, there's a ruler on the wall that goes markings like that to measure his height. Okay, and then let's say the teacher of the boy looks at the boy and try to read off his height, maybe using by putting a book there on his head and looking at the marking on the ruler. Well, and then writing down the height of the boy. So let's say the height of this boy is maybe 1.15 meters, right? Now, and then another girl comes along and the height of the girl is measured, and that's 1.21 meters. And then a boy comes and teacher measures the boy's height, and the boy's height is 1.09, and so on. Okay, now after measuring the whole class, maybe 20, 30 of the boys and girls, now the teacher found a problem. All right, let's say the teacher found that the ruler on the wall was not placed with one end exactly on the wall. It's a little bit higher up from the ground. Maybe it was higher up by a small distance, right? By a small distance. So that's the actual zero of the ruler, but it's a little bit above the ground by maybe about 1 centimeter. So by about, say, 0.01 of a meter, right? So that's 1 centimeter. Now, so what this means is that, for example, if a boy is actually 1 meter tall, the ruler will measure, the marking on the ruler will measure him to be taller by 1 centimeter. So as a result, there's an error in all of these readings that the teacher has taken so far. They are higher, these numbers are bigger than the actual height of the boy or girl by 1 centimeter, 0.01 meter. So what this means is that they all have the same error. Now, this type of error is called systematic error. It's an error which is the same for all of the numbers that are measured. So that's what we mean by systematic error. It's a fixed amount of error. Now, systematic errors, once we found it, they're quite easy to correct. Meaning that, for example, in this case, since we discovered that all these numbers are bigger by 0.01 meter, that all we really need to do is to go to these numbers and minus 0.01 from each of them. Right? If I minus 0.01 from this one, I get 1.14. 1.14, and then minus 0.01 from that one, I'll get 1.20, and then minus 0.01 from that one, and then I'll get 1.08, and then I will get the correct values. So that's systematic error. Now, the other type of error we look at is called random error. Let me take a look at that. So that's random, and write it out. R-A-N-D-O-M, random error. Right, what's random error? Now let me look at another example. Let's say we have a pendulum. Now a pendulum is quite easy to make. Just find some place to hang a piece of rope, maybe at the edge of the table or the chair, and get a little ball or little piece of stone or wood, and tie a little bit of string to it. So let's say that's my little ball, blue color ball. Okay, I'll tie a little bit of string to it and hang it to the edge of the table, and then I pull the ball to one side and let go, and it swings, all right, to and fro. Now I take out my timer or my watch, a stop clock, and I'll start measuring how long it takes for the pendulum, after I release it, to come back to the same place. How long does one swing take? Now, and then I'm going to start the stopwatch when I alright. Then I'll write down the numbers for the time, for the seconds that I measured. Alright, so let's say the first number that I got was 0.25 of a second. The next number that I measure, so I'll start again and measure another cycle. Let's say 0.23. Okay, and then I measure that again, and I'll get 0.06, and I can keep doing that. And what you'll find is that the numbers is sometimes a little bit bigger, sometimes a little bit smaller. Now, the reason could be because we have to start and stop the stopwatch, and we might sometimes start a bit early and sometimes stop it a bit later. So, and it keeps changing. You know, sometimes we're a bit faster, sometimes a bit slower. So it's quite random. So these are random error. There's no fixed pattern to it, unlike the problem with the ruler, which was off by the same amount from the ground for every measurement. In this case, every time we start and stop the stopwatch, we could make a slightly different error depending on how fast we respond to the pendulum. So these type of errors are called random error. There's no fixed pattern to it, and it can keep changing, and the answer can always be a little bit different, but it will always stay around perhaps some average value around